Good morning. My name is Mr. Flatt, and I'm here today to start another new exciting unit in our grand theme of how trigonometry and mathematics ties with alternative energies. Today, we are focusing a little more on solar panels and how those can be used in real-life applications. But in order to figure out how we could bridge solar panels with trigonometry and other mathematics, first we need to learn a little bit more about what solar panels are attached to and how those might be used in the real world. So the main project goal here is that by the end of this lesson you'll have ideas on how to install solar panels properly angled on a roof. In fact, rather than even just a roof on a house, for instance, to gain the best angle of light from the sun, you'll also have the abilities to design some kind of art sculpture maybe that uses solar panels on it. So in order to do that, how would we know the proper angles and alignment that these solar panels need to attach to this roof in order to get maximum sun exposure? How can we even approach that? Well, let's look at some of the tools you're going to need. First thing first here, let's look into the Pythagorean Theorem. So in your Google Classroom, for your math class, you'll see a link there for follow along guided notes. So you're going to have to open that up right now, and you can either print that out or start filling that in as you go. At the end of those guided notes, you'll see several challenge questions. These questions are going to ask you some, we'll go into those, but those are going to be your homework assignment. There also is a quiz in the same section at the end of the Pythagorean Theorem lesson. It's all tied together in the Google Classroom there. So you're going to need to have that completed, a pre-assessment quiz for when you come into class tomorrow. All right, let's get started. So first, Pythagorean Theorem. So this Greek philosopher named Pythagoras developed an idea that bridged together that if you have two sides of a triangle, side A and side B, you will actually be able to calculate side C. In order to do this, you need to use the equation a squared plus b squared equals c squared. This may be novel and new, or you might have seen this in a previous math class, but let's take an example of how this might look in action. We're just going to jump right into it. Say we got a side that's 3 feet long and another side that's 4 feet long. This might actually be something like a part of a roof, like half of it, half of a roof on a shed or something, maybe 4 feet by 3 feet. So you can imagine this is already getting some real life applications. If it was 3 feet tall up to the pitch of the roof and 4 feet across, we could take those numbers, we could square this side A plus the square of side B, and that'll give us side C squared. So let's take a look at that. 9 plus 4 squared, 16, equals C squared. Well, we know that 9 plus 16 is 25. That'll give us C squared. But we're not done with that yet. This is actually saying an area, something squared is an area. So we're going to need to square root this 25. And if we square root the left side of the equation, we need to square root the right side of the equation. Now we're left with 5 equals C. Or our third side, C, equals 5. So that just gave us the length of this hypotenuse or the longest side of a right triangle. designated by a box here. This needs to be 90 degrees. All right, so if that were a shed roof or a house roof, you would know that the base is 4 feet long, the height to the pitch is 3 feet, and then this actual shingled area on one side of the roof is 5 feet long. Excellent. So let's prove it to ourselves in a different way. If you've got a right triangle, that equation is actually saying that this side's squared. So let's draw a square. Let's draw a box. Okay, so this area right here, this side's squared plus this side squared. All right, well that's got to equal this whole side squared. So let's draw a box here. So it may not be exact proportions on here, but on your paper, on your guided notes, you'll notice there is an exact proportion with broken out units that you can follow along and actually count the units of how many blocks are inside this square plus how many blocks are inside this square, and they will fit inside this last square here. So in your worksheet, you'll notice there's a challenge problem talking about a ladder going up to a house. So here's your little house here. There's the roof. You need to put a ladder here and get up to the roof. But you need to follow the OSHA standards and not put the ladder too close to this roof. So your challenge is to figure out how close with the OSHA standards of 1/4 of this height here. So 1/4 y. So this is a y height. This x distance can only be 1/4 of that y distance. So figure out how those clues can help you determine how close this x distance has to be to the house. The second problem you're going to do is a challenge problem involving helping your aunt out, and you're going to try to help her put a TV up on her TV shelf. You're going to be given the distance of a shelf. So here's her little shelf here. And she's going to want to put this TV up there. Well, she wants to have another shelf on top. But she doesn't know how high to put the shelf. So you're going to help her with that because she knows she's getting a 36-inch TV. So what I want you to do is look up, what's that mean, a 36-inch, or not 36, this is 36 inches across. On your paper, it's I think a 42-inch TV. So look up, what does that mean when someone gives you a TV size? What actual dimension is that? That's for you to discover. So once you've figured out those problems, tomorrow we're going to dive into the law of sines. Because just as a little precursor to tomorrow, what if say you want to design a triangle that does not have a right angle? An oblique triangle. How would we solve that? Can't use Pythagorean theorem. All right, so in summary, the Pythagorean theorem will help you solve for any side of a right triangle, and this can be applied to our overlying theme or our project involving several different entities, several different curriculums like science, business, technology, by allowing you to design a roof to fit a solar panel installation. And you'll be able to design a distance here that will give you the angles you need to direct this solar panel towards the sun. Thank you, class, and I look forward to seeing you tomorrow.